when you have the addition of another radical term, the steps remain the same. Right? So you don't even have to change what you did. We isolate our radical expressions first. But this time, you don't isolate both of them. You pick one. So isolate one radical. Okay, so you can pick either one. It doesn't matter which one you choose. I'm going to isolate this root 3x. So we do that by adding root 4 minus x to both sides. Okay, the second step is to undo your radical. Okay, remember, when you undo your radical, you basically just square both sides. Okay, so when we square the left side, no big deal. But when we square the right side, it changes. It's a little more complex. Okay, the left side, we just cancel the radical, so that leaves a 3x. But on the right side, you have to still account for that binomial square expansion pattern. So we square the first term. 2 squared is 4. We're then going to take double the product of these terms. So you treat this whole square root of 4 minus x, multiply by 2, and then double that. So you get plus 4 root 4 minus x. Again, it's just 2 times root 4 minus x is 2 root 4 minus x. Double that, you get 4 root 4 minus x. And then we're going to square the last term. Well, squaring the last term, again, just cancels the radical, leaving the bases as itself. So notice what this step number 2 did here was it eliminated one of the radical expressions. We still have one, but we've reduced it from 2 into just a 1. So the next step is going to be to solve the resulting equation. And notice the resulting equation is an equation with a radical. So we're just going to repeat these steps. Isolate your radical. So we're going to get this radical alone on one side of the equation. Okay, so we'll add x to both sides. And that gives us 4x. Here we combine what we have. We have 4 plus 4 gives us plus 8. So we're going to subtract 8 from both sides. And that's equal to 4 times the square root of 4 minus x. We can still look to isolate. If you can isolate your radical completely without creating a fraction, I would do that. So here you can divide every term by 4 to eliminate this number without leaving a fraction. We get x minus 2 is equal to 4 minus root 4 minus x. We can undo this radical. Now we move to a step where we undo the radical again, which involves squaring both sides. Okay, on the right side here, it just undoes, cancels with the radical. On the left, though, once again, we have to account for the binomial square expansion pattern. So we square the first term, double the product of the terms. So x times a negative 2 is negative 2x. Double that, we get negative 4x. And then square the negative 2 to get a positive 4. Okay, and now we're going to solve this resulting equation. Okay, we do have multiple terms with variables, so we're going to put everything on one side and set it equal to 0. So we have our x squared. We're going to add x to both sides. So minus 3x. We're going to subtract 4 from both sides, so those cancel. And so now what we can do is solve by factoring, remove a common factor of x, set each of your factors equal to 0, and you get your two potential solutions here of 0 and 3. Okay. So notice right here, you probably need to repeat the steps 1 to 3 before you move on, and you come up with your, again, required step of check your solutions. Okay, so when we plug in a 0, we get the square root of 3 times 0, which is 0, minus the square root of 4 minus 0. Does that equal 2? Can you take away a value from 0 and be left with a positive? No. So we know that that's not going to work. Test for 3. 3 times 3 is 9. The square root of 9 is 3. Minus 4 times 3, or 4 minus 3 is 1. Square root of 1 is 1. Is that equal to 2? Yeah. And so the only solution of that that works is the 3.